Welcome back. This is the very last lecture for the Objective-C programming course, and we'll also have our very last lecture for the iPhone course after this one. I'm going through my notes and I'm kind of looking to see what I've missed, and I've got a couple different lectures. One of them was this one. I'm not quite sure if I started it or if we got halfway through, so it's kind of weird to pick up in the middle of a lecture, so I'll just kind of start in. Skip through the beginning of it and just going to make sure I cover it. And then the second half of today, we're going to go over what's on the final exam, which will be next week. And so that's the kind of the game plan for today. So what are we looking at here? We're looking at a lecture on view controllers. I was recapping on the model view controller because I normally start out the course with model view controller and then I end the course with model view controller. And then in between, we kind of see the model, the view, and the controllers. So this is kind of the kind of the tail end of the material. So hopefully at this point you've got a good handle on this and you know what this concept is about. And what you're looking now is making sure that you've got multiple model view controllers and that you're designing your applications using this concept and managing them. And last time, I believe, if I remember this correctly, we looked at the storyboard. We may have done this in the iOS class, we may have done it in this class, or in the iPhone application development class, but what we did was we created a storyboard and we created multiple controllers that worked with multiple views, and we pushed and we used the modal and the push to connect the views together, and then we had separate controllers for it. So this is essentially the big picture. Now all the UIs can't fit in one model view controller view if everything is separated out. So looking at the big picture, I think I covered this part last time, but I'm not really sure. Well, what happens when your application gets more features to it? Well, if you design your application for growth, which means you design it so that you can, hold on one second. You know what? I didn't get the attendance. I totally forgot it. Huh? It's locked up. How can you get it? Ask Joel for it. Okay. Thank you. If you start out with a blank application and you just start building it, you get one view, one model, one controller. When you start adding features to it, you start working with it, and then what ends up happening is you lose sight eventually in terms of the design. So if you keep this in mind and you start adding more controllers and more views, then instead of this where you've got multiple levels of controller and viewing going on, and the kind of the abstraction sort of looks like that if you don't organize it. What you really want is that, where you've got the three components per each activity or per each area. So what happens if your application gets more features? Then you'll never have a model view controller view span across screens, hopefully. And you'll create a new view controller, model view controller for each one of the new features that you have in there. So think of them as three components that work together, and for each new feature you have a new set of these components. And if you think along that line, what ends up happening is your app makes a little bit more sense. Will it still work? Yeah. Will you still be able to run it? Yeah, no problem. But when you go like 5 more years from now, or 1 year from now, or a couple months, or if you show the work to somebody else, when they look at it, they'll be trying to figure out what in the world you did with this. And it's more confusing. And not only that, but the files get pretty big. And they get pretty overwhelming very quickly. So here's the concept again, looking at it and just keeping in mind that your chain of activity should go back and forth between the view, and then this is the controller. It's working with the data that's also working with the view. You'll have a couple questions, and I'll go over in a few minutes what's going to be on the final, but there's a good percentage of questions on this concept actually. So use a controller of controllers to keep track of multiple controllers. So we've seen tab bar controllers, we've seen controllers of controllers actually, bar controllers. And here's one here for UI navigation controller in this particular example, where we have UI's navigation controller, which is pretty much the controller of the controllers, and then we build it up another hierarchy. So we have the view, the model controller, but in this particular case, they're all separated out. So we can add a controller for the controllers, and then we bring it all back together. The storyboard, in some sense, is a controller, but it's more of an organization. It's not necessarily a controller in the same definition. So, but we have different navigation controllers, tab bar controllers. You can actually create your own custom controller as well and add it to the project. So here we are Again, the UI navigation controller is the controller whose view looks like this. Well, what is it really doing? It's taking us to these other two activities, these other two views. So in terms of putting it all together, we have this concept of the root view controller, which is held by the, we usually tell the app delegate which controller is going to be the root view. And then the root view is going to keep track of all of the other controllers for the most part. So it's a special because it can be set as a root view controller outlet to another model view controller. So this is how we're configuring the hierarchy using the root view controller. And I'm sure you've seen that terminology before. And hopefully you've seen it in a couple of different projects we've built throughout the course as well. And here we have, we'll embed the model view controller inside of the view. So sometimes it actually has its own view. If you look at the tab view controller as the root view controller, it has its own view. When you run the application, you can't really see it, but it's the underlining structure that all of the other views are loading inside of, if you take a look at that concept, or kind of think about what's going on in the background, I should say. In terms of working with them together, the UI element in this particular case, the UI buttons and the sub-view components are again part of each of the individual views, and they can be I can never say that word, Segue, to other model view controllers, and appear in the UI navigation controller as well. Some people use this bar as a navigation controller as well because you can put buttons on the bar. And for a navigation controller, it's actually not bad because then you can easily nest controllers inside of controllers, and then you have a really nice hierarchy for a navigational purposes. So. Anyway, if we take a look at the concept, what we're pretty much accomplishing is, some people like the picture, some people like to see the source code. This is just a picture of what the last project we actually put together with the multiple views. And then up here, you can sort of see the difference here. We have just the items in here, and then the title bar, which is the navigation controller, which is blank, and then here we put a button up here to go back. So we're going to navigate the controller back to the previous view. So, but some things like the title bar will stay consistently among, especially if you put it in the root view. If it's in the root view controller, then everything else gets loaded underneath it. So notice the back button here automatically appears for us. If we set up the design correctly, then we can actually use the controller behavior for us, and we don't even have to put the button here. as long as this view, as the navigation controller loaded up another view, we'll get the back button automatically. But for the most part, you're probably going to build it in pieces, and you'll select your own back button or your own forward button. Or sometimes you see edit buttons and things up there, depending upon what's being loaded actually inside of the view component itself. So, all right, and now what are we looking at here? When you click on the back button, obviously it goes to the first model view controller. So it's navigating back and forth. These slides are kind of a lot of them for a little bit of concept, little lovely pictures, and now this one's going back to the beginning. So we're switching between the UI view controller, switching between this set and then this set here. So it's going back and forth. So we looked at this concept last time, the Segues, which I can never pronounce. Segue. I know. I think you even corrected me last time as well. The Segue. So, but when I look at it, I never think of Segue. I think of Segues. So I'm not quite sure. I don't know what happened to the TA, but you can leave it right here.
Me down, but I was printing interesting things for Surgeries.
Okay, no problemo. All right, thank you.
But I'll go flag them down.
Okie dokie.
I want to discuss something with Ellen.
Okay.
Since I was kind of in the scene, I just came to.
Okay.
All right.
Thank you. All right, so this is what we looked at last time in terms of the concept, and I believe we used the modal or the push to go from one view to another using the segue. So to create a segue, okay, let's say segue, hold down the control and drag the button to the other view controller from here, and this is what we did last time live. So this is the lecture that kind of came back. So I'm sort of catching up with this lecture. We've actually done the project already that worked with this. When we do that, we see the lines that go in between. We get this with the storyboard, but we get this without the storyboard as well, just because we have the storyboard with all of the screens that show up automatically. We can still use segues and we can still use multiple views. We just add them manually and then we connect them together. So, and so we did this, and when we do this, we create the segues by using buttons or using click events, and we just say on this, and it gets created for us automatically. It's actually not inside of the view controller, it's inside of the segue that gets in. This is the segue here. Why do they call it a segue? I don't know, but yeah. I call it a connection, actually. And last time we actually gave it an identifier, and this one was, I can't remember what the theme was, but we were going between one and the other. And so when we give it an identifier, then we can call it in the code and actually use it. So the identifier here is called show other in this particular case. And so we can have a prepared for segue sender and use show other, so that when we have one view and we're going to the next view, we use that prepare for segue. In fact, we did this in the code actually to, I don't know, gather some data from the first view, do some calculations or something, and then prepare information before we load the second view. And so when we do that, we can send some information to the new view, or we can populate it somehow with other information. So you can programmatically force the segue with a perform segue with identifier, which means go there. So if the user stays on the screen long enough, it'll actually take you to the second screen of some sort. So here you can change the segue type here by clicking on the button. We did this actually last time as well. We have the push, the modal, and the custom. We've actually used both of these in two different examples. The push here is what we're going to use to control the two of them, one inside of the other one, and then for the UI navigation controller. And so here's it's pretty much going to, both of them are pretty much going to do the same thing for you. They're going to show it, but on the push, you can actually, when you go from one view to the other, you're pushing it inside of the same controller, so you can animate the view versus just switching. So it's more of a animation control over it. There's a few different features that are associated with it. So they're not inside of the same one. So in this particular case, the push isn't going to do anything. And then down here, is initial view controller can be set on the initial scene. So we can set a parameter on the view controller for the particular view, and if we switch this controller, then the push will actually, that'll solve the problem. The push will actually work. So the arrow that is to the application starts and here, and will basically go to the view controller that you want it to go to. So it's a way of programmatically setting the view controller for the particular view, and then designing the behavior that works with it. So here's another one here, double clicking on the background. See, everything makes everything smaller. I use the plus and minuses down here to make everything smaller, controlling the zoom. So we figured that out as well when we started looking at the big storyboards. They get kind of big. So, and then we have the embedded in feature where we can embed a navigation controller inside of another one. So here we can embed a view controller inside of a navigation controller with the edit button. We've actually done this as well. We did it with a tab bar controller, I believe, but we may have done it also with a navigation controller. And then noticing that the application starting point has been preserved. Obviously, it has been, because which is kind of funny, because they put this empty arrow that just points into the application, meaning that this is the starting point. So without the navigation controller, it started here, so it just moves it back one level of the hierarchy. Think of this more of a hierarchy if you want to. Okay, it shows you the difference. And then clicking on here, you can actually adjust which one's going to follow next. So this is not a segue, it's a root view controller outlet. So all of the navigation controllers, tab controllers, we don't really have that too many custom controllers that we can use as root controllers. Don't really show us anything. They're not really visible. What's mostly visible are the view controllers. So this here doesn't push to this one. This one just loads for us automatically. But this is the underlying controller mechanism for the main screen that's going to load. So In fact, you'll see that if you just make a brand new project, bring up one of the templates that uses a view controller, uses a root view controller, like a navigation controller, and it'll show it to you automatically. So here's your UI navigation controller looking at the view, the UI view that's obtained from the view property of the UI view controller, most recently pushed to the root. So this is just showing an example of some information. It looks like a mailbox actually, of accounts that are loaded in. So a Gmail accounts it looks like in here. So and using the navigation controller. Yeah, that's all he gave me.
Okay, that's good.
Yeah. You might want to ask him for the other one.
Oh, I'll ask him.
Yeah. And here we've done this actually. We've put a title on the navigation controller as well. So this is just kind of a review of the concept because this should have gone along before or probably around the time that we did that tutorial actually. But the title is a string, so we can write to the title. We've done the titles actually programmatically. We can also do the bar at the bottom of the screen. In fact, we drag it over and we stick it on the bottom, so we can get a title for the bottom if we wanted to as well. And we have toolbar items that we can drag and drop on here as well. And these are actually just toolbar items that we put on here, one for editing and one for refreshing. So. And then the button on the top, I believe there's by default 3 button locations. You can put one on the left, the right, and the center as you would drag and drop and put them down. So what do we have here? In terms of the functionality, when does the push model view controller pop off? We actually saw that, in fact, if you remember that example, we were able to flip the pages, and then after a while, it wasn't garbage collected, so it froze on us, or actually kind of covered up part of the screen when we were flipping the pages. It's interesting, it's still on a stack, and it stays on the stack until we garbage collect it, or until the system garbage collects it. So unless we garbage collect it, it's not going to, unless we get rid of it, it's not going to go away. So usually because the press is of the back button shown on the previous slide, we're going to leave it on the stack. So it happens programmatically as well. So we can go pop view controller animated, which means move it off, go from one layer to the next layer to the next layer. So this is the same thing as clicking the back button. So I think of the concept as when you have the navigation controller running, we're loading views on top of views on top of views, and we're stacking them up, and then we're just popping them off when we want to go to a different view. That way we don't keep loading it up into memory and unloading it, loading it, unloading it. We're just essentially going back and forth between the different ones. So, what's this example? Here we have a database record, deleting the button with the action, delete current record. So we used a different example than what was in this illustration here for the example that's in the slide set. We used I can't remember what our thing is. I think we just had colored background pages, I think is how we demoed this. If I'm remembering this right. It was 2 weeks ago, so I have to remember. Other kinds of sequence besides the push, we have the replace, the pop over, the modal. In this class, we've actually just seen 2. We did the push and the modal. There's the replace, which replaces the right-hand side of the UI split view. Only works in the iPad. It actually has a different screen on the iPhone. And then pop over, which puts the view controller on the screen in a pop over iPad only window. We did the pop over, believe it or not, last time as well. I think that may have been in the iOS class. I mean in the iPhone class. The pop over menu that we built last time was an example of that. And then the modal, which puts the view controller up in a way that blocks the app until it's dismissed. So, which is not that much of a, it's just going to essentially put up a screen the same way until you get rid of the screen. You just can't go back to the previous screen that's underneath it. Not like you can, and you can't see what's underneath it either. Or the custom one where you can create your own custom class. That I would say is probably never going to have a need to create your own custom Segue unless you want to do some special animation, or you want to do like one of those e-reader flipping the page kind of thing. Then you can create your own custom Segue for that. And again, you're putting in some animation with that. So no, we're not going to talk on Tuesday about iPad related issues. We actually already covered that stuff. So let's see. Firing out the segue from the code. We've actually seen this stuff, and this is what we did. We did the prepare for segue, and we didn't do this. We did not do this theme, but we saw this. So this was just kind of the recap of the textbook information that kind of goes along with the tutorial that we did last time. I couldn't remember if we had covered that or not, actually, but now I know we definitely did. So I also uploaded along with that an example called the Psychiatrist that goes along with it. It should be at the bhacker.com website. Let me just refresh my memory which category I stuck it in. Let's see. I believe it is in the iOS, but let me, or excuse me, not this one. Let's see. It will probably be, these are the ones we've been going over, by the way. View controller, these I believe are going to be the ones vc1.zip and vc2.zip, which are going to be these two here. Yep, VC1, View Controller 1 and View Controller 2 are the two examples. Instead of doing tutorials on it, I put an example together. Actually, I used an example that was given to me from a text. And let me show you what this is doing, actually, so I can kind of show you the concept. Rather than building it, we just figured we've built enough projects at this point so we can see what the finished product looks like, and you can kind of see the concepts on steroids. So this particular example works with all of the other, all of the things that were demonstrated in that lecture, except for the theme is on a psychiatrist. So if I run it, let's see, I'm going to run it on a, set for an iPad simulator, so let me see. It might use a split view controller. Looks like it is using a split view controller. So which is not a custom controller, but yet it's a nice way of creating a root view controller that controls a couple of subviews, and we'll see the subviews show up in a few minutes. So we can sort of see what that looks like. And up here it is. So if I click on the little guy over here, we have the split view controller. So what I've done then is, this is the root view controller with a navigation bar, navigation controller, that's putting up the split view controller. And that's going to change, so this guy's got the little sad face on him. So depending upon what Freud and Dr. Phil have to say, if you press the buttons, it'll change the happy face. So I'm flying all the time. What do you see in your dreams? So now he's smiling. And steel apple with a bite taken out, chased by dragons. So you can see that the buttons are essentially just changing the picture. So, and I believe we're probably going to need to get the same effect after Dr. Phil. Here we go. I want to be on TV. He's kind of neutral with that. So let's take a look to see the differences. In fact, you'll see why people like the this would work the same way as an iPad mini as well as the iPad. But the split view controller is giving us the two screens that come through. If we load this guy on a iPhone instead, we're going to see we actually have to switch screens, which is the same concept, but we have to go back and forth. We're not going to get a split view controller on this. But it's automatic. It's one project with one type of controller that's going to work the same way or similar way, hopefully. But again, we have the screen that pops up for us, which is, oops, no, this one's not going to do it. On a couple of, you can design the controller so you can. I can't brush it because I don't have. I can't swipe it, but on a swipe gesture, it will show the happy face, and then I swipe it back, which I tried to do with my mouse, but it doesn't work. So we have go back to Dr. Phil, and so now we go to Phil's website. No, let's not do that. So you can kind of see the navigation works a little bit differently for the different type of project that we're working on. Well, what are we actually looking at? If we take a look at the storyboard, with the storyboard for the iPad has the controller in it. Let me make this a little bit smaller so we can see it. Get rid of the side piece. Now it's too small. Let me make it a little bit bigger. Get rid of this side piece. You can see we have a lot of little screens associated with it. This one is for the iPad here. Or excuse me, yeah, this one is the iPad. So we can see the view controller. Let me make this a little bit bigger. The Splitview Controller, which is controlled by the Navigation Controller, which has got a rotatable view controller and a happiness view controller. So this is a custom view controller that was created from it. So we have a ton of view controllers, but what do we really have in this application? We have a couple of views. So we have the psychological view controller, and then we have the screen that has the buttons on it, which is going to be our view controller for a psychologist. So we have nested view controllers in this particular case. That's going to lead us to nested views that are in here. And then according to the iPhone layout, it's going to be a slightly different composure. Let me make this a little bit smaller so we can sort of see it. Where we get the navigation controller by the rotatable view controller by the two other view controllers for each one of the different views. So although that looked like a fairly simple application we just looked at a few minutes ago, we can, and the reason why we're looking at this is so that we can see, wow, there's a lot of view controllers. More so than you'd think. We saw two different screens. We saw one screen with a menu on it and a split view, and the other screen with a happy face on it. That's a lot of screens. I shouldn't say it's a lot of screens, but we have different view controllers. So we have the rotatable view controller. Now, if we were to rotate, I can't demonstrate the entire app to you, but if you run it on a real device, you can actually kind of sort of see it transform. The split view controller, which is going to be the main view controller that's going to be working, navigation or the root controller. And then this smaller view controllers that's going to work with the individual views for the different components. So we have the happiness view controller as well. Then we have the face that shows up. This face is the same face that we saw in the previous example that we did the week before. So kind of a quick run view on just to show you the concept. There's another one in here I'm going to talk about in a few minutes, because there's a little bit of overlap between the first lecture and the second one I'm going to give you momentarily, which not quite as complicated in terms of the number of controllers, but equally as interesting to look at. This one has a navigation controller that works with a card chooser view controller that goes to a card display view controller. So it's really demonstrating a really nice, in fact, the only reason why I'm showing you these apps is to kind of give you the design to show you what it should look like, in terms of the number of controllers. So you should have something that's a main controller, and you're going to have a designated root controller, and then you're going to have something that, each one of your views is going to have its own view controller that's going to work with it. So in this particular case here, we're not using too much in here. What we've got here is a card display view controller and a card display .h and .m combo and a card chooser .h and .m combo. And then we have a separate class that's working with the card plane, so the card view itself. So let me just demonstrate what this is doing. It's just going to show you different cards. And what it's doing is it's picking different images to show in an image view with what you have selected, given the name of of what you've clicked on. So let me take a look at the finished app. It's actually kind of cool. Let's see it run. So if I said, I can use to go through the, choose a card you want. I can use a picker on that. And so now I've got 6 of, what is that? Clubs, thank you, for card players out there. I know this one hearts. Let's see. We'll go 5 of hearts. There we go. So these are just stored images of cards, and then we're changing the title with the name of the card. But it's kind of an interesting Interesting design. It seems pretty complicated. It's really, you saw the screens a few minutes ago. It's only 2 screens. One card view controller, one navigation controller. This is the navigation controller up here that's working with the going back, which is automated. So if we take a look at see what we're looking at in terms of the code, the implementation, this is the .m of the card display. So it's, well, there's a ranking. It looks like there's a setup for ranking in here too to rank it, but we're not going to worry about that. The display is doing nothing more than showing, well, it's using an NSUI integer and NS string for the suits. That's going to be for, it's like title and things. Supporting files, we can see card chooser the app delegate for the card chooser is going to be in here as well. Let me take another look here. Here's the face images, so no mystery. We've got, I didn't even see those. These are the jokers, huh? So, different cards actually, but I didn't even see that part of it. But it's not. This is actually a partially implemented example. It's not fully implemented yet. What you're supposed to be looking at is the controller part of it, in terms of what it is you're showing. So we'll take a look here then at the example that kind of goes through how that is formed together. And that one I believe is this guy here, the number 2. So on the selection, what we're doing is we're updating the title in that example with the title that's associated with whatever the user selected. So we have a collection of UI bar items as well that we're working with. So we know how to do it. We've done it before. We just drag over from the library. We put the bar button up here and we put a name on it. And then this is actually giving us the psychiatrist example. What we're looking at then is being able to customize it. We can add other items to it. We actually have some built-in properties that are associated with it as well. If we were to take this navigation bar example from the psychologist example we just looked at, this would show us our, our UI toolbar on the bottom, our navigation controller, all the different parts of it. So we've actually built one of these live. So see if there's anything in here that would be of interest that we haven't gone over yet in this class. No, we actually didn't see this part of it either. The example that I gave was the stripped out version of it. So, no. There are some different options. In fact, the UI toolbar, this is an interesting slide to look at. Since we've built similar projects, I'm not going to bother going through the rest of that. You can go through it at a slower pace on your own if you'd like, if you refresher. But we've actually done all of this stuff before in previous examples. This is sort of the concept on steroids, though, in terms of an explanation of it. The UI bar button item. We have the generic item that we bring over. Then we have the edit, the back. We have some built-in predefined bar button items that we can add to it. So usually you drag it out, you put it on there, Allocation methods are associated with it, the target action like UI buttons. So they're created just like the UI buttons are, where there's an IB action, IB outlet that's associated with it. And you can drag it over to the view controller and wire it just the same way as you're wiring the other buttons that you're working with. So you can also put images as well on the toolbar, as well as text and other items. And then you can set the justification, so something is centered or something is to the left or something is to the right, which is kind of interesting because if you put it in as a right bar button item and then another right bar button item and then another one, which is what sort of they're doing here, what you end up with is everything side by side, and then you can pad, add some padding in between the buttons so the buttons aren't touching each other. If you'd like to get a, kind of a spaced out look. Don't believe this one has any padding on it though. So. And then for the UI Splitview Controller that we just saw, I don't know if we actually, this is the pop-up, this is actually a pop-up, which is what we saw last time with our pop-up menu. What we did last time, if you missed it, was put on the bottom, if you refresh, I know we did this last time, we had bar button items, one for edit menu and one for something else. We clicked on the items and it brought up a menu, and we used that menu to as a pop-up or a pop. Actually, I think it was called Pop Over. Pop Over was the name of the project. So we kind of made our own like menu items to kind of fit into there, which is what this calculator is doing. So as an example, you built a tic-tac-toe game or you built a calculator. You can bring it up inside of as a popover menu, even though it's a regular old view or it's some other sort. It'll show up with this motif and look like a popover if you load it as a popover, is what we did essentially. Which is, you know, allocating it and loading it up as if it were a regular old menu item, but or menu option when you select the button, I should say. So let's see, the Splitview Controller, you just drag it out, put it on the storyboard. If you have the storyboard for an iPad, it doesn't work in the iPhone. As you see, it will show, but it doesn't show as a split view because the view is not big enough to split. And then it's over the base UI element only. So you can't like nest it further down. It has to be on the highest navigation level. And then you have setters and getters for each one of the two views. So you're going to show it, show a particular view for the left and for the right view. So I don't have any other examples on the split view, so I'm going to sort of just see if there's anything in here we have not seen yet. We've seen the view controller delegate. There's a separate view controller delegate for the split view controller, by the way, because following through the model view controller, the same way as you have a tab view delegate, tab controller delegate, you can have a split view delegate, which you get automatically when you drag and drop and stick a split view over. And it's just a component you're dragging from the library that you're sticking over there. So, oh, this is our popover universal application. Actually, the universal application, we did the popover last time. We haven't really worked with too many universal applications in this class, but for the most part, it's one of the newer options. So universal application will run on an iPad or an iPhone. So it's a single binary image that runs on both. How do you create one? Well, you use the option when you create the project. And in terms of what it is, how do you figure out am I an iPad or am I an iPhone? You can actually put in a little check here, so Bullion iPad equals, and then take a look to see what we are. It's kind of like how web pages take a look to see, well, what web browser loaded us. We can actually have the app identify what it is and then do something differently depending upon what it is. And then have a universal app that works on both. So for the most part, though, a lot of people don't do a check on it, and they just have the app prepared so that it shows up small or it shows up big, depending upon which type of device you're actually running it on. When you are working with Splitview Controller, though, you can load a Splitview Controller on an iPad, but you can't do it on an iPhone. So it might be a good chance to kind of check to see, well, what device is this app running on? Have the device check the app and then change the controller given the different device that it might be looking at. So code conditional on whether or not you're on a screen or not on a screen. And how big the current screen is, well, you can actually get the screen bounds and resize things for the most part. So you can tell whether you're on a big device or a little device. So, which is kind of interesting because iPad applications look fine on an iPad mini, but they look kind of scrunched up on an iPhone. Although they will actually work. You just see things a lot smaller. So the best solution is to identify, well, what device, and then given the device, change the orientation of something or change how something, what's going to be displayed given the device. So. Alright, so today I'm just kind of playing catch up on a lot of stuff. So this one here is supposed to be the last one, and it's a review of Objective-C. But what I'd like to do simultaneously is go over the final exam. So what I want to do is, I have the exam with me. Let's see. And so as I'm going through this, I'm going to go through as a prep, because for those of you who have been paying attention, next week we have the final exam. And the final exam is approximately, or it is exactly 25 questions long, so it's not that long. And I've got some multiple choice. I've got 9 multiple choice questions. And then I've got from 10, let's see, 9, 10, 11, 12, 13 multiple choice questions. Oh, 14, 15 multiple choice questions. So out of 25, there's 15 multiple choice and there's 10 short answer. And the 10 short answer are going to have you write some minimal code to see what, to see if you can remember a few things. But for the most part, they're just writing definitions of things, explanations for things. So what do you need to know about Objective-C? So this lecture is about 44 slides and it goes through everything associated with it. So as I'm going through topic by topic, it's kind of like a nice way to kind of conclude with some thoughts on certain things and then tell you what you need to study for. The concept of property and synthesize is on the exam. So, which is the first topic here that we're looking at in the slide. And the concept of the interface and the implementation file. So at interface, at implementation, properties going into interface, synthesize going into the implementation. There's at least 3 questions on that concept. Not a bad one to be familiar with. Why properties, most importantly, to provide safety. Safety and subclassability of instance variables. So also provide value for lazy. They call that lazy instantiation, actually. What you're doing is essentially, instead of saying get, you have in this particular case, we have a variable called speed or something here. So also provides value for lazy instantiation. Okay, so if we have nothing, we just have a regular old variable we're going to call it speed, and we're going to use it to keep track of an integer. Lazy instantiation would be we're going to instantiate it to 0 or to 1 or to 2 or something. And we're going to, if we do property and synthesize on it, the at property is going to allow us to kind of automatically generate the setters and getters versus, because you can actually just say integer speed if you wanted to. So you can say at property. So instance variables is not required to have instance variables backing up a at property. And you can just skip the at synthesize as well, but we normally see them in sets. Some properties might be calculated using read-only or something like that rather than stored. And it is possible to have instance variables without a property. But for the most part, if you use a property and a synthesize with your variables, as well as your components on the view, it makes everybody talk together, and it kind of does things for you automatically. Yes? I'm sorry?
Is this PDF available also?
Yes, it is. It's available online. It's the last one in the set here. It's Objective-C Foundation Notes. It's the one that says review. It's the last one in the slide set. And the ones I was just going over a few minutes ago are these last ones here, lecture and example, lecture and example. Nice little review slide set for the final. It's this one right here. Okay. Yeah, you're not the only one who probably would have that question. That's a good idea to ask that question. Why the dot notation? Well, it's pretty. We can use dot notation. We can also use the message, the opening and closing bracket with the name of the object and the message we're going to send to it. So it makes access to properties stand out as well. So we can use dot notation for it. Just know that you can, but you don't have to. Makes access to properties stand out for normal method calls. Synergy with syntax for C structures, actually. Do you know you can actually use C structures with Objective-C as well? And it uses the dot notation. So syntactically, C structures look more like objects than with properties. So 2 big differences. You can't send messages to C structures. And C structures also never allocate in the heap. They never actually have automatic allocation or deallocation. Yeah?
I have one question on the C structure.
Yeah.
Can we use this part of it when we are defining the property? Can we use the type to say MS string member? I have a problem.
Yeah, you can do a property as of any type, yes. You're not going to do a structure as a property. You're going to create a structure. Just like you would do in C, actually, and include and make an instance of that.
If I'm defining, say, name as string string.
You're going to call the structure string?
SN string.
Okay.
I can do that.
You can have a property of anything,
Okay.
any legal variable type.
I have the-
Any legal data type, instead of using it as a regular data type instantiation, you can do a property for it. Yeah. Structures, however, aren't Objective-C, they're C. So they have a few differences with them. They're required to use the dot notation with it. You can't use the message calling, the standard Objective-C message calling technique with them. You have to use the dot notation. Here's an example of a structure if you've never seen one before. So the dot notation, the at property access looks just like the C structure method access in this particular case, where we have here we have the CG point that's defined of a structure. We're just doing a type define on a structure. So notice that we capitalize CG point just like a class name. So structures usually have a capitalized name as well. And it makes the C structure seem like it's an object with a property. But except for you can't send any messages to it, which means the opening and closing brackets with the object space the message. So, and as a special side note, you want to be familiar with both syntaxes, both the dot notation and also the way of sending a message to an object in Objective-C, using an object name, instance name, and then a space, and then the message you want to send in. So here's just an example here using, we have the CG point here, property CG point position. So this is a structure, so we're creating a property using a structure that we created. You can mix and match them is what this is trying to tell you. So just because a structure is from C doesn't necessarily mean you can't use it in Objective-C. And you can use it as course. Here's another answer to your question right here actually. We defined a structure and then we used the structure for a position. And we declared it as a property. So we have with the at property. And then we have an interface here, knowing the syntax for how an interface is created with a colon and then vehicle. And then we have an implementation of vehicle in another file. And then in here we have the properties specified out along with the method prototypes. So our dot notation here as an example, self.center.x. And we have a floats here of x and a float y. And we're creating an instance of this through the property. So, and this is going to be a float left edge. It's going to be equal to this. Right edge is going to be equal to that. So don't worry about this particular example. Just remember that structures can be used, properties can be used, they can be used together, and we're using a dot notation for it. So yeah, here's the center.x, which is this x in here, and then the dot notation for self. So, and knowing that self is like this in Java, it's self, it's the main object that we're looking at. So strong versus weak. Actually, the concept of garbage collection, I'm going to go back to the exam right now. The concept of garbage collection, automatic reference counting, and alloc and retain and release. Not so much on the syntax, but on the concepts of using memory. So the strong versus weak concept is also on this exam. Strong keeps whatever you have in the heap doesn't garbage collect it. So it won't point to any, even though it won't point to anything anymore. So keep it in the heap until I don't point to it anymore, theoretically, and won't point to it anymore if you point to it to nil. So if you set something, if it's strong or weak, actually set it to nil, it'll throw it away because it means you're not using it anymore. So like in the C language, when we use a pointer, assign it to a new something, and get rid of that new something, or assign it to something else. We don't generally set it to nil, but nothing really happens for us. In Objective-C, it actually gets rid of us, takes us off the heap. And we're still using a heap concept, actually. So what's the second bullet point here? Or if I myself am removed from the heap because no one strongly points to me. So when we have a strong, we stay on longer. We're not garbage collected. So if we're weak, we keep as long as someone else points to it strongly, or whether or not, so me versus somebody else, and if we get thrown away off the heap, set the pointer to nil automatically does it for us. So if a user's on iOS 5 only. Actually, the 5 or above, I should say. It's one thing of the past is weak never got set to nil because weak always got garbage collected. So it depends on who is pointing to it. If it's itself was pointing to it, somebody else is pointing to it, and how are they pointing to it? Are they pointing to it strongly, or is it a weak? So strong or weak point to it. And where do you get that syntax from? How do you know if it's strong or weak? Well, you look at your properties. In your properties, you see you can set the property as strong or weak. So as we've been going through the course, we've been using weak for everything because why not? You know, no one's really going to point to us as being strong outside of our simple apps that we're building. However, if you set it strong, you may have a tendency to run out of memory eventually, especially if you have something that's constantly pointing to it, and because it's on the main UI or something, and something's actually being using it constantly, then it may never necessarily be deallocated. Did you have a question?
Yeah, if it is strong, then we need to say release.
If you're not using automatic reference counting, then you have to retain and release. If you retain it, it means it makes it strong. If you release it, it makes it weak. You're not necessarily going to get rid of it. It's the garbage collector that's going to get rid of it. So there's a way of making it not garbage collected, or there's a way of telling the garbage collector, if you want it, take it. But it's not necessarily going to get rid of it. But there's no need to get rid of it instantly anyway. I mean, unless you're running out of memory, and then the garbage collector will get rid of it. So one of the things about garbage collection is essentially knowing that in a language like C, C++, you're going new, delete constantly. In Objective-C, you don't actually have to do that anymore. You can, if you're going to do that, you're going to allocate, and then you're going to release or retain. Release is going to be the delete. Retain means don't delete. Which, because it works with pointers, so the reference pointers, which you're not actually managing, the operating system's actually managing it for you. So automatic reference counting deals with the concept of reference counting. This is another concept that's also on the exam. Reference counting keeps a 1 or a 0 on or an off, which is a weak or a strong setting. So think of weak and strong as an on or off in some aspect, because if it's weak and you're running out of memory, it's the first to go. If nothing's counting to it, no reference to it, it's going to be a 0, first to go. But is it going to go if you don't run out of memory? Probably not. It's going to stick around. It's going to hang out. So weak and strong just says, you know, if I'm pointing to it, leave me alone. If somebody else is pointing to me but I'm not pointing to it anymore, then let it go. Because that might not necessarily be current. Or something of that nature.
But both of them will be taken care of by garbage collection.
I'm sorry?
Both of them will be taken care of by garbage collection.
Yeah, but all of it will be taken care of by a garbage collector. Yeah, it's not garbage collection, however, which is the next point on here. This is not garbage collection. It's way better than garbage collection. It's reference counting. It's done automatically for you. So when saying new and delete, that's kind of like garbage collection when you're in C or C++. That's garbage collecting. In reference counting, you're just keeping track of what's being used, what's not being used. Because what you're going to do is try to find the environment is going to find a victim. The victim is going to be whatever is not being referenced. And only find a victim if you need the memory. If you don't need the memory, don't worry about it. Just leave it alone. So sometimes, even without automatic reference counting, you can allocate, never release anything, and still not have a problem. But if you create a bigger application, you might. So finding out what you're about to leave on the heap, well, you can do a deallocate. So a special method called dealloc. It's called when an instance memory is freed from the heap. So without a CR button clicked, you can still do it. You still have to alloc. There's no way of getting around not having to alloc. You always alloc, you always initialize. But you don't necessarily have to dealloc. Because if you have automatic reference counting going on, the engine's going to do it for you. The operating system's going to clean it up for you. However, if you're doing it yourself, you do a dealloc. And that says, okay, make you, when we go out of scope, then clean up your memory, get rid of you. So you rarely ever have to implement this method. It's too late to do much before useful here. Actually, you can't really do anything useful here. So in the default project type, you have used to have a dealloc method. You don't have it anymore, not with especially, well, you'll have it if you don't use automatic reference counting. But nowadays, if you click that little box, you're not going to see any of this stuff anymore. So the concept of memory, the concept of property and synthesize, concept of how to run methods with the dot notation, or how to get data with the dot notation, and also with the, there was no example in this review, but the passing of a message to an object using the brackets, you know, what we've been looking at so far in the code. Concept of nil is also on the exam as well. In fact, ID, before I forget, is also on here, the ID data type. So let's see. Actually, that's question number 2. So let's see. Nil has an object pointer that does not point to anything. Same thing in C or C++. ID here is a generic pointer. It doesn't have any particular type to it. It's just like a generic reference in C or C++. It's like the asterisk. ID is a generic object type. And so we have object that equals nil. And nil is not pointing to anything, which means it can be freed to be garbage collected, which is why we're saying, you know, have it equal to nil. So here string hello is equal to nil, which means we haven't really used it yet. Also important to know, the NS for next step in front of everything, like for example NS integer, NS string, NS object, all reference because they're all objects. So anytime you make an instance of or use an object, you're treating it like a reference variable. So you always have to have an asterisk in front of the name of the variable that you're creating because you're creating it as a reference object. You can't use them in a non-reference environment. So just remember that point. That's also an exam point. So like 0 for primitive, integer, double, etc. Actually, it's not like 0, it is 0. Actually is equal to 0. So you can test to see if it's equal to 0. If it is, then you know it's empty. It's nil. So all instance variables start out set to 0. In fact, if you've defined a variable, don't initialize it to anything and then print it to the screen, it'll have 0. In fact, if it's a string, it'll be 0. If it's an integer, it will be 0, which is kind of an interesting point. So it starts out with nil. And you can implicitly test if using the if statement. So if object, curly bracket, in here, the syntax here, with the opening and closing, you know, curly bracket to execute the object pointers to an object to see, does it point to anything or is it nil? And if it does point to something, then do something. If not, do something else. And then send messages to nil is mostly okay. No code gets executed. So what are we doing here? Method which returns an integer. So I is equal to, well, here's your other syntax here for those of you who are not familiar with the other. If you're not using dot, you're using this notation here. The sending a message to an object here, which is going to be equal to I. So this is a method which returns an int. So I will return if object is nil. So integer I is equal to object return. Okay. We don't see the code for that, but just take that at face value. Let's see. Yeah, the C structure is not an object, it's a structure. So in that particular case, it's not going to return nil. Only objects return nil, only objects are initialized this way. Non-objects don't use a pointer, they don't have nil. There's no automatic initialization. So if I said integer I and printed out I, I'm going to get garbage. If I say, you know, ns integer I and print out I, I'm going to get 0. Because ns integer is an object, integer is not an object. So, or int, int. So. Let's see, Bullion. Let's see if there's anything else on that. So ID was not mentioned in there. It's probably mentioned further down the road, but the ID concept is also in there. The interface, let's see. The location for where you're putting in variables is also on here. We know that they don't go between the opening and closing brackets, curly brackets. We know that variables go above it. Excuse me, that variables are inside of the opening and closing bracket, and the methods are not inside of that. So the basic structure, if you've ever built an iPhone application or an iOS application before, those concepts associated with where you're putting things, that's also on the exam. So knowing that you have opening curly bracket, closing curly bracket with the variable declarations if you're going to declare them that way, and then underneath that set, that's when you have your at properties. And you knowing that that at symbol is a compiler directive, so the at, at telling the compiler, actually here it's probably, I was going to say it'd probably be better if I open up an app, but the compiler directive to say, NS string is equal to at symbol and then opening and closing brackets. So say my string is telling the compiler, hey, this is a string. It's called a compiler directive. So that concept, I don't see it in here yet, but I wanted to make sure I mentioned that. It's also on the first page. So. Alright, so Bullion is also supported in a language. Objective-C Bullion type actually is just a type define. Can be tested with this, a flag, if flag, is it true or false kind of thing. So yes, yes means true, no means false. So no is equal to 0. Yeah, yes is equal to anything else. So flag is equal to yes, flag is equal to no. So instance versus class methods. Remember the pluses and the minuses. That's also on the exam. So we have the minus, or the dash, or the plus. So we know instances start out with minuses. So it starts out with a dash. So the bomb is a class. It lives in the heap, and we'll pass it another pointer to it in this particular case. So this one is associated with an instance of an object that were created. Plus starts with a plus symbol here, which is going to be our class level. So we're going to create something that is going to apply at the class versus the instance methods. And this whole structure thing is not really of interest to me, so I'm going to skip the explanation and just use this as kind of a summary of what it's on the exam and just point out what to look at. Starting with the dash, I call it a minus symbol. That's a normal instance method. So calling the syntax here, we have the pointer to the instance, and then we have the method. We know how to call a method at this point. And then calling it here, we usually have the class name along with the method if we're going to use it by a class level. Same thing you get actually in other languages when you create class methods. You don't call it by an instance, you call it by a class. So if the class was called printing, it would be printing space print me. And then if it was an instance, it would be printing my printer, and then my printer print me, or something, depending upon whether or not it was a class or an instance. So creation and utility methods, usually done this way. We've seen this with protocols and with categories, actually. So here the ship is an instance, ship, and then the class is the instance method called class, returns class. Do something is a class method in this particular case. So it's important to know the differences between the pluses and the minuses, not necessarily just the symbols, but also the meaning of it, instance versus class. And then what do we have down here? Super and self, also a concept to be familiar with. In fact, let's see, super and self. I had a question on that, and I believe I took it out, but I'm just checking right now. Not a bad concept to be familiar with. I believe I took it out, actually. I did take it out. Alright, so you don't necessarily need to know about it, but super and self is calling an instance, super self is calling a class. Self is going to be my implementation, super is going to be my superclass's implementation in the same context. So it depends on whether you're calling on the class. It means the same thing in both contexts. Is one is going to refer to the instance and then the super object's entrance, or it's the self. So methods. This is still on the exam. So super and self was taken off, but method and the concept of methods are still on there. So more examples here using the syntax for the method declaration. It's important to know, in fact, do you have to write a method? Let's see. I believe. No. You do have to declare a class with 2 data members. Yes. There is one question on the exam that has you declare a class. I can read you the question actually without the name of the class. Declare a class blah 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 in Objective C and include blah blah blah. Write both the .h and the .m files. So a little, you know, and then you have plenty of room here on the exam to do it with as well. So you're going to have a couple methods and some couple data pieces that you'll have to put in this class. So keep that in mind. You know how to create a method. So here's some examples of it if you've never seen this before. So you've all created methods before. Know how to make instances of objects as well. What do we do here? This is a overkill for what you need to know actually. Instantiation, asking other objects to create objects for you in a strings object. Not all objects. Well, let's take a look at the basic concept of the instantiation, which is on this slide here. Alloc and init. Know how to make an instance of an object as well. I know I have a question on there. I won't read you the question, but I'll just tell you that it works with the one in which you're going to create an object. And you're also going to have to make an instance of it. So, know how to make an instance of it. I'm not going to give you the theme of the object because then that would be way too easy. Yes, you want to know how to make an instance of an object. And this is how you do in here. Also, be familiar with the concept of initializers. So, what is an initializer? How do you write an initializer? What is in the name of an initializer? Well, the word init, obviously. It's very straightforward, actually. It's not too bad. But to create an initializer to make an instance of, to do something. If you remember initializers, the most important thing is to initialize super. So you're going to go and you do something with super, and then I'm not going to write it for you. You can look up. Yeah, you know how to do it. You can look at that up. I would highly recommend looking up how to initialize the super object. It's like about 4 or 5 lines of code. It's not too bad. So there is some code writing in 10 of the questions, actually. A short answer type code writing. It's not hard. It's not hard at all. If you've been following along, if you've actually done all 6 assignments, you'll be able to ace this no problem. In fact, I'd be surprised if you didn't ace it, actually. So now, allocating and initializing an object from scratch, doing this in 2 separate processes. Know that you can alloc and then initialize. You can do them together. You don't have to run this initializer. You can run another initializer, any initializer you want. The concept of a convenience constructor, which creates and initializes the object all at once. So we create convenience constructors. Other languages, they call them constructors, and you just write a constructor, initializes the data for the object. Well, in Objective-C, they call them convenience constructors, and you're basically initializing and allocating inside of the constructor. And then you might be setting some data members and things. Initializing the data is the same concept of the constructor, but you're usually performing the alloc and the init all in one, so you don't have to do it out in main. Makes it easier. That's why they call it a convenience. It makes it easier to construct the object. So both steps must happen right after each other instead of one inside of the other, so you can put them one after the other if you want. So allocating, it's a heap allocation of the new object with NSObject. So we have a class method ID alloc that actually runs, and if there's enough space, it will actually create the object, and then the ones created by the synthesize also get created. In terms of the initialization classes, they have multiple different initializers. Know that you can have more than one initializer with arguments added to the plain old init. Init's the default initializer. So if a class can be fully initialized with a plain init, then it can. Otherwise, you can create different initializers. More complicated init methods. Here's one here, init with frame, as an example over here, where we can add. Oh, that's the other thing too. This is a good slide to kind of point out this. Know how to pass parameters. You know that we have named parameters for method calls. We can say, in this particular case, we can say, you know, this is actually named init with frame, but it's not. It's just the name of the initializer. And we're sending it the perfect frame as the parameter. But then we can have a space, then we can have another something, another word, colon, something else, where we can put a name in there so we know we're setting side A, side B, side C, and we can label each one of the parameters. So know how to create and use parameters when you're calling methods. That's also on the exam. It's a multiple choice question actually. So you don't actually have to write anything with parameters. It's a multiple choice. Here's an example of multiple initializers with different arguments associated with them. We've seen here's init with characters, init with format, init with data. So, and classes must be designated must designate an initializer for subclasses. So classers, it's a typo. So the initializer of the subclasses must use the initializers themselves. They're designated initializer. We know how to do that because we're doing it inside of the initializer. So we're telling super to do something with it. So let's see. You don't actually have to know anything about static typing of initializers, but the return type ID is not statically typed. This one is. You don't have to worry about that. And here, actually, here's your code. Here's the code I told you that you might want to look at. Here's the super init. So I believe I took out the super question because I have it in this one, so I left it alone. So in here we have self is going to be equal to super init, calls the super's designated initializer. So then we have if self, return the self object itself. So be familiar with this right here because you might actually have to regurgitate it. So with the class that you're creating, actually. It's not as hard as you think, actually. It's not so bad. Here's another way of setting an initializer with self is equal to self init. So another instantiation. I'm not going to, there's nothing, just the basic initializing concept. There's nothing on the exam that goes to this level where we have a convenience initializer or a convenience constructor. There's nothing on convenience constructors either. But this one here is just giving you yet another example on how to run the initializer this way. And this is inside with an init with valid operations, so it's another initializer that's setting the default initializer, and then it's assigning, you know, some array that's going to be equal to nil or something. So self is going to be equal to nil. Alright, so just the use of pointers and dynamic binding. So as I mentioned before, all of the objects that are allocated as pointers, where the non-objects are not allocated as pointers. So if you saw some code and it had an object and it was using it and it wasn't using a pointer, it would probably be wrong. If you had a multiple choice question or something of that nature. So objects are allocated in the heap, so they're always using a pointer. And so this is the NS string, which is kind of classic. Anytime you see NS next to anything, it's always a pointer. So, but here's ID object is equal to S, not statically typed, but perfectly legal. Why do you think that's legal? Because ID is a pointer. ID is a pointer itself, so it would be like a pointer to a pointer. Never use ID and a pointer together. That would mean a pointer to a pointer to a... It's a pointer to it. It doesn't say a pointer to an object. Well, it is an object. It is a pointer. So the word ID is a substitution for the asterisk, actually, which makes us a generic. So if we say ID object, so object can be anything. Object can be a pencil, it can be a pen, I don't know, any type of object that we had, that we created, any object type. So decisions about the code to run on a message sends whatever happens at runtime. So the word and the meaning of dynamic binding and dynamic allocation are also on the exam. In terms of the dynamic, here we go. We have dynamic typing, dynamic binding, and dynamic loading. All words that are present on the first page of the exam. In one question, actually. So, and it has to do with dynamic binding, actually. But knowing that nothing is assigned until runtime. And if nothing is assigned until runtime, it's the opposite of static. Static means it's allocated at compile time. So before the program even runs, We know how much room to allocate for an integer. If it's dynamic, we don't know, which means if we do a dynamic, generic ID, it could be anything, which gives us flexibility. So the concept goes above and beyond flexibility. It gives us more options in terms of the design of the language, and then more capabilities in terms of object assignments. So static typing, i.e. in a string versus ID, purely an aid to the compiler to help you find bugs in the beginning. So in essence, everything could be an ID. We use the data type, for example, NS string versus an ID. So just in case we're using an NS string and we're passing it and it's really accepting or looking for an NS integer, or it's looking for a number and we're giving it a string, and then we have compile time binding, or excuse me, type checking that's going to happen. So if we don't give it a type, it's not going to do type checking for us, and we might have something that crashes or doesn't work. So it's illegal and sometimes even a good code to cast a pointer, and we're casting with the ID. And here's the example here, where we have NS string, and we're going to call the string S. It's going to be equal to an NS string. Well, give me an NS string of OBJ. How do we know that OBJ is actually, object is actually a string, or string compatible? Well, even if it's a number, it would convert it to a string. But if it's a string, we want to take it to a number. It's like hello world. And we said to do the opposite, take it and put it into an NS number. We might be doing something that might be dangerous in terms of the cast. So knowing it's legal, it's worthwhile. However, it could lead to casting errors and problems further down the road. I think I've actually gotten off of the first page. I'm on to page 2. All that stuff's on the first page. Okay. Second page. Let's see. The second page is dealing with the interface and the implementation files, the .h's and the .m's. You do have to write a method, by the way. And in most of these questions, it will say only use Objective-C syntax. I don't want to know, because I know that you can use and you can create methods in C++, or C, actually, well, C++. You can use, but on the exam, just keep in mind that you want to use, when in doubt, use Objective-C syntax for everything. Don't put something in C, because then that would definitely defeat the purpose of taking an Objective-C course. But I have tried to put on every one of the questions, in fact, here's how it says only use Objective-C syntax. So just keep that in mind. Let's see, we have here object typing here. What do we have in here? Vehicle, ships, alloc, shoot. So, an example of an object here. No compiler warning, perfectly legal. S is a the is a relationship. Let me see if the is a relationship is in here actually. I believe I may have left it out. No, but I'm seeing something here I didn't mention is the auto release pool. There's a question relating to auto release pool in here. I don't know if I mentioned that already, but there's one in here. And I left out the is a relationship, so next time I write this exam, I'll have to make sure I put that in. So you don't have to know about the is a relationship, but if it's in the hierarchy, and if a ship is a vehicle or a car is a vehicle and they're all of the same hierarchy, then they all have the is a relationship, and they all can use, because it's all dynamically allocated, there's no question we have copies of each one of the identities in memory. So depending upon how we're using it, it'll use the methods that are associated with the object type that we've created or using. So this is under the object typing category. Let's see, V is a ship, compiler knows V is a vehicle. Which is actually kind of interesting that it's a compiler warning and not an error message, actually. Because of the dynamic nature of it, we could technically have a method that matches it. And it's not going to know it until runtime. So a lot of the information is, a lot of the typing is delayed. So we get a warning that says, hey, there's a possible conflict, but we're not quite sure if there's going to be a conflict. There's a warning, so let's not worry about that. Object typing, object typing, object typing. Introspection. Knowing the ID. We had a tutorial called Introspection or Introspect, where this information is actually coming from. So what do we use an ID for? It's not always a bad idea to use an ID. We can get at the object as in terms of the object type. So this is actually more of an object typing type of question as well. We've seen these methods here: is kind of class, is member of class, response to selector. There is an introspection question on the exam on the 3rd page. So, along with another properties question and reference counting question and an ARC question. Wow, there's a lot of memory. There's a lot on ARC, reference counting, and garbage collection. But there is one on introspection, and it has to do with one of these 3 methods here, actually, which basically is more tuned towards the tutorial we did in terms of figuring out: are you a text box? Are you a button? What are you? Are you a kind of class? In better words. Returns whether or not an object is a kind of a class. You know, are you a form of a box? Are you a form of an image view or something? And then arguments to these methods, they're a little tricky because you have to basically check to see if the object is a kind of, and then list the type of object, meaning you have to get the object type correct. Are you a UI view? Are you a, are you a this or are you a that? So if you're checking it correctly, then you know you're a string or you're a number, kind of thing. The selector, there's nothing on the selector, by the way. It's is a kind of class type of question, and it's a multiple choice question as well. So the method testing methods take a select or SCL select, the special selector directive. We actually saw this with the same introspection example. So we didn't see, I don't know, actually I think we did actually see this in another example as well. It's an Objective-C type of selector. So it's the object type selector, and you're going to be a selector shoot, your selector shoot at. So again, it's not something on the exam, but something we have seen in the class. As a kind of final review, it works with the concept of being able to get at what it is and what methods it actually contains to see if, do you have this? If you have this, run it. So you don't try to run something that's not on the object. Let's see what we have here. More on the introspect. The foundation framework. Let's see. So I'm still on page 2 here. See, instance variables. There's a question on instance variables. There is one on dynamic behavior. I've actually covered everything on page 2. Page 3, there is a foundation. Let me hold on one second. Let me tell those people to get out. All right, so there's a question on the foundation framework. I'm trying to see what it's about actually without giving the question completely away. It has to do with an import. It's an extremely easy question. If you've never attended this course before, you might not get it. But if you have ever been here for one class meeting, you probably will get the question, no problem. It's an extremely easy question. What is the foundation framework? Well, from the object perspective, it's the NS next step. So it's giving us our Coca foundation, Coca Touch actually. And it's the base class for pretty much every object in the iOS SDK. What are we looking at here? We're implementing introspection methods on NSString as a description. Oh, NSLog. NSLog is on here as well, actually. It would not be an Objective-C exam without NSLog. NSLog is, there's a question on, it's a multiple choice question actually, and it has to do with the syntax of NSLog. So be familiar with how to write an NSLog message. And it's the at in NSLog here in this particular example. So do we have an ID copy, I don't know. Raise an exception. Not, well, don't be familiar. You don't have to worry about anything on this slide outside of what the foundation framework's about. We're looking at Coca Touch versus Coca. There's an actual next step history question, and it has nothing to do with the year either. If you were here for the next step lecture back, oh, I want to say in the first part of the course, maybe in the first couple weeks of the course, you'll get that question, no problem. It's a trivia multiple choice question. Think about where it came from. The history of next step, or NS. And the question is kind of too easy, actually. So it's like the foundation question. It's really easy. I'd be surprised if anyone misses it, actually. I shouldn't say that because then people feel bad if they do miss it. There is a question, and it's not on the slide. I haven't seen it yet, but while I'm thinking about it, there is a question about because I'm seeing mutable string here. There's a question about arrays, mutable arrays and arrays. It's on the data types that we have in terms of dynamic allocation. It's again, I want to call it a trivia question, but it really isn't. It's not a syntax question. It's a concept question. But I'm seeing NS mutable string here, which is why I wanted to say. There's mutable versions. So just like we have mutable strings, we have mutable arrays. And this one here, mutable version of the NS string is somewhat rarely used. Actually, it doesn't need to be used, which is why it's rarely used. Arrays, mutable arrays would be a little bit more useful for the most part. Because strings can grow in sizes anyway. We don't necessarily have to set the size of a string. You're going to do some things with an NS string that you can do without a new one, in place changes and stuff like that. So, from the foundation network, we know we have NS number, NS value, NS data, NS date, NS. Just think of NS as next step and how it's part of the foundation framework. There was an entire lecture on this entire concept, so it's further up in the document set, but that's not a bad one to review. There's only here's our NS array. There's only one question on this, and it's more of a trivia question than anything else, actually. So in terms of our NS array, we know that we have the NS mutable array that goes along with that, and that's more the mutable part of it, which is in this previous slide, is more of the concept. I don't want to give you the question. I'm beating around the bush a little bit because I don't want to actually give you the subject matter of the question. It's in this particular area of context, though. I think I've said enough about that one without actually telling you the question. All right, so here's our mutable array. Mutable version of the NS array. We also have dictionaries, by the way. So, all right, not to give you the entire question away, but have some familiarity with some of the data types, because there's a multiple choice question that lists a bunch of them, and there's, A has a few options, B has a few options, C has a few options. Now I'm getting down to the question itself. Some of them don't look like they're real data types, but they are. Some people will look at one and go, that ones that look like C data types. And then you look at other ones that say mutable this, mutable that, mutable dictionary, and you look at, and that's the dead giveaway, because people will go, oh, that's wrong, that can't be right. Because I've never attended an Objective-C lecture before. They have no idea that these are actually illegal data types. But then there's some of them in there that have data types that aren't real either, in some of the options. So that's where you're going to see this mutable everywhere, because mutable looks like it's fake, doesn't it? Like, how in the world can you have one that says changeable, NS changeable array, and NS mutable array? How could that be possible? Arrays are fixed. They're not mutable. Here's our NS dictionary. So what you don't want to do is go through and memorize, the slide set here has got, NS number, NS value, NS. Don't go through and figure out which everything one of these things are. Just be familiar with the concept of the multiple different data types, and that they can, all data starts out with NS. And we have mutable versions of some of them. So here's the dictionary. And we have the mutable dictionary. And we have mutable strings, actually, too. And we also have sets. Mutable set, mutable sets here. NS set and mutable set. Usually we have capital M, capital S as well. So it uses what they call that camel case or something. in the wording. So, NS ordered set, mutable ordered set. So all of them come with the mutable everything. Enumerations, looping through members of collections in an efficient manner. Enumerations are enumerations, same thing you get in C actually. Language supports using for in. We didn't actually program with this, and this is something I don't use very much of, but you can, and I don't believe I have any information, excuse me, I don't believe I have any questions on enumerations on this exam either, so I've left it out. Nope, no enumeration questions. But not a bad idea to know that it's supported in the language, just for the future. Here we have an NS array of NS string objects. We can say for this for a string in my array, then do something. So it's an easier way of kind of using the in kind of syntax to say for everything in this set. So it's a set manipulation. So. But we don't need to know about enumerations really for the exam. Term property list just means a collection of collections. So we have a property list basically specifying out data, dates. So an NS array is a property list of all its members. So we have a NS array or NS string is a property list as well. Because inside of it we have subcomponents. So think of it more like a collection. I don't believe I have the term a property list. This is vocabulary at this point, which turns into plist actually. This is more a topic for the next class, actually, not this class. Nothing on, so here's what's not on the exam for this class. Nothing on Coca Touch interface, nothing on iPhone, nothing on iPad, nothing on iOS development. Nothing on anything outside of the Objective-C language. It's primarily focused 100% on Objective-C language. This is the Objective-C class. So property list is going to be a stretch for an Objective-C class. It's more of an iOS concept, and I do have a plist property question on the iOS exam. So not a bad idea to be familiar with it if you're taking both exams, but for this one you don't need it, actually. Nothing on user defaults either. So you could skip the last two slides in this review as well. Alright, so the goal of this was to kind of go through and use this kind of, this is the one that's called review, and it's kind of a nice little recap of all of the concepts that we looked at in the class. Again, there are no questions on anything having to do with Xcode either. No Xcode questions, no iOS questions, no app development questions on this exam. It is primarily focused on the Objective-C language. Let me just take one last little peek through the exam to make sure I haven't missed anything. A lot of things about creating objects, actually. Running methods on objects, the initializer. Several different memory-related questions. I think it's a little too memory-focused, actually, but there's a property synthesize question. So, yeah, I think I've given you everything, actually. It's not too bad. I think it's actually fairly straightforward. It's not, of course, I can say that. I'm looking at it. I think it's pretty straightforward. If you've attended the lectures, if you've been listening, it's a nice little checkpoint, actually. In fact, you'll walk away pretty satisfied that you know the stuff. Because if you read the questions, you'll go, oh, I know this, oh, I know that. It's like, and you'll actually kind of sort of be surprised how much you actually remember, I believe, as well. The people who are going to have problems with it are the ones who don't show up on a regular basis, who have no idea how Objective-C is different from other languages, and I think it's just a dialect of C, so they're going to answer everything with a C perspective, which is kind of an element that's written into the exam. There's a lot of answers that give you fully good syntax in C, which is wrong for Objective-C. So that's to trip those people up, essentially. So, questions, comments, concerns? No? Then I guess we're going to be done a little early for this class. I've run out of material. All right. Alright, so I kind of went through it on a little fast side, but I'm looking at my notes here and I'm pretty much done. I don't have anything else left to give you, so we'll call it quits then.